The field we're stood in at the moment has had an onion crop followed by a winter barley crop. The proposed next crop is outdoor pigs, and what we're doing at the moment is trying to find out whether or not there's any compaction. So we've chosen potentially the worst part of the field, which is the headland, where all the onion harvesting machinery's been turning, and the combine that's been harvesting the barley. And there is compaction in this part of the field, so that we know that for outdoor pigs, that's something we'd need to remove before the pigs are stocked. Very easy to find compaction. The thing you've got to bear in mind is it could be occurring at different depths. Quite often it'll be very shallow, and there's some compaction that's basically just below the surface, really caused by the harvesting operation. Further down in the soil structure, probably about ½ a metre down, there are large platy lumps of soil which have probably been caused by onion harvesting, and it's really important that both of those are removed before pigs are stocked. They're both signs that compaction has taken place in the soil structure. It's important to establish the depth that the compaction lies at, because that will determine what piece of equipment you need to remove it. In the case of the field we're looking at the moment, the compaction is basically being caused by harvesting operations, so it's very shallow. And you can see if you look into the hole that there's a shelf, and that's where we're getting these compacted horizons from. Is from a shelf probably about 4 or 5 inches deep. So removing that is not going to take a lot of horsepower, and it's going to be relatively easy to do, and it wouldn't be too difficult to do the whole field just for safety's sake. What we can tell from this hole is that in the main the topsoil is very, very well structured. It's friable, it falls apart very easily, there are no compacted layers in it, and if you contrast that to the soil that we've just dug off this compacted shelf, you can see the difference. A lot of horizontal plating, and that's going to need removing before outdoor pigs are stocked. This is a really good example of subsurface compaction that's caused water to stand in a vehicle wheeling, and you can clearly see there that there's compaction just below the surface. And if you contrast that to the soil structure in the bed next to it, you can see there's a massive difference. And this is something you'd need to take into account once the onions have been harvested. That subsurface compaction in the wheelings is still going to be there, and it's something you're going to need to plan to remove. Just to re-emphasise the importance of soil type, this field is a field of loamy sand. It's recently had potatoes harvested from it, and yesterday it took 20 millimetres of rainfall, and you can still see it's very well structured. It's dried very quickly. In this case it's loamy sand over sand, and it drains very, very freely, and it's possible to dig even in the vehicle wheelings, and there's almost no compaction. So this really should be the preferential soil if you can find it, loamy sand. Just to re-emphasise the quality of loamy sand in terms of inherent drainage, it's the same field, it's had 20 mil of rain on it, it's had recently harvested potatoes, and you can see behind us, despite the slope and the tram lines, no water's run down those lines at all. Okay, well what we're looking at here is a subsoiler, and this is a bit of kit that you'd use to take out deeper compaction. If the compaction is at a very shallow depth, say 10 centimetres, then something like a chisel plough will remove it. But if it's down below 12, 14 inches, then this is the kind of equipment you're going to need. The critical items with this piece of equipment are the depth at which you set the working and the angle of the plates at the bottom. In order to shatter the compaction, you need to get underneath it and lift it. And you can only do that if you've got the working depth correct, and if you've got the angle of the heads correct. You need to be dragging it through the soil, lifting the layer that's compacted and trying to shatter it to improve drainage. Now these are the wings, and these are actually the items that are doing the work. And while it's important that you get the angle right to get the maximum amount of lift, it's also very important that this is carried out in dry conditions. If you try and subsoil in wet conditions, you'll simply deform the soil, and the amount of shatter will be very, very small. It's really important to get the angle right in dry conditions.